Welcome to a new test and teardown video. This time it's another German signal generator. This one is from HG Neuwirth in Hannover, and the MS stands for Mess Sender, so that means it's a test sender. For you, I don't know exactly what that is. This is special, and it's because this one is a special version made for, I don't know if we can see this, but this is the Danish military. So, and this is 1966, by the way. So, since this is a special version made for the Danish military, everything here is written in Danish. So that means the intensity, and this means internal or external modulation. So that's a little bit funny about this unit. There's also another thing that I found different on this model, and that is the mains entry. See, my wire here goes from the back and not via a hole here in the front, like you see on the internet if you go and Google this version. It is about 16.2 kilos, so it's quite heavy. We got 7 tubes in this unit, and what else can I say? The 10 bands, that is a little bit interesting. This is of course a normal IF frequency because 455 kilohertz is here. And then this is one of the HF bands. So you need to have the 1.8 megahertz. And you also need to have this HF band. And then 10.7 megahertz is a very known IF frequency. Then again, very good HF bands. But again here, now there's an overlap, see? From 28 to 42. And then 41 to 60, 59 to 90, and so forth. Now we got overlap all the way to 260. But we haven't got any overlaps down here in the low. So we got a lot of holes. As you can hear, this is a very big carousel switch. I got this today. And look, it looks brand new. It's in perfect shape. And I actually think I know why. Because the guy that gave me this one said the mains transformer is blown, and it has been like this forever. So that is why this unit was never used. Because the mains transformer blown up by some wrong voltage setting or something like that. And they never repaired it. It has been just standing for the last 60 years and not being used. So of course I have to open this one and inspect before we can go any further. We're now inside, and the mains transformer has been removed. And it looks like there's evidence of a minor explosion, and that is also what I was told. We have all sorts of debris pieces all over the place. So I don't know, how is that possible? Or is it half of the rectifier, a high voltage rectifier that was mounted here probably? Here is a new, more modern power rectifier. And inside this unit I find the schematic from Radio Museum. So thank you very much, Frank, for doing that. I'm quite happy about that. So of course I also went to Radio Museum to look up the schematic, so I had a nice digital version, and I've been looking a little bit in detail here, and I cannot find any voltages on the high voltage. So how much is the high voltage? That is not written, and that is a little bit annoying. But I also don't have on the schematic the different voltages, but it was written here on handwriting, right? So this is the 280 AC that goes to the high voltage rectifier. This is 220 mains. And then we have two 6.3 volts that goes to all the tubes and only one of the tubes. And that has something to do with the way the power supply here is made, because you can't have from the cathode a very high voltage down to your filament. So that means this filament winding for that tube needs to be an individual isolated filament winding. And then all the other windings, or then there is one more winding on the transformer, the 6.3 volt here, that goes for all the other tubes, all the other 6 tubes. So, yeah, there is still a little bit hope for this unit. I can just go and pick up another transformer from my stash. And there's another little thing that worries me a little bit here inside this shielded box with all the oscillator stuff. Look at that. The back side of all the screws. Then we got some press nuts or something like that. I think they are made of zinc, nickel, something like that. Look at the white powder here on all of them. It's completely nasty corrosion. Oy, 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 this is bad. And this is just all over the place. So I'm not sure I'm able to take out those screws. See? I need to clean this up outside. So I'm still trying to get inside this lovely box. And it's of course full of screws, and they are really, really tight. And I think it's because of this corrosion that went up through the threads. I'm just super happy about my mega long screwdriver. See? It actually fit to solve this. So this is definitely a super duper trick for you guys to get those super long screwdrivers to solve these things. Otherwise, there's just no way. Oh, a little bit more inspection here, and I find really nasty corrosion, and that's again made from a special alloy. This is why it's looking so bad. This is of course iron, and that is just normal rust. And so this reveals this unit was stored in a nasty wet shed or something like that. We also got some corrosion on wires even. This is not a good start. Not for... yeah. But anyway, I need to go and look inside the different boxes, and then we'll see. Oh, by the way, this is the way they made the tuning from that tuning knob with a nice coupling like that, and this is why it runs so nice and smooth. This is a good way to do it. So now we are inside this unit, and as you can see, its main design is very similar to another design or another product by the same company, the FUP. So if you see my previously released video about the FUP, you'll see it is exactly the same mechanical solution. And this is a very good way to do this. The way that they milled these grooves and the way this brass is soldered together. And the fun thing here is the whole chassis here. That's actually iron because it's magnetic, and it's somehow soldered to the brass. So I think they probably coated this or attached some sort of copper or something so they could solder on the steel, right? Together with the brass here, and you see the pieces of, I don't know, yeah, from this angle here you can see that, right? So this has a self-centering way to lock into those grooves. But anyway, that's a quite good shielding chassis. And here is the carousel switch, and again, like the FUP, this is a TV tuner unit. So this mechanical piece here is exactly what you will see in the 60s and the 70s television sets. That is so funny. Definitely exactly that unit. And here in the bottom again, they're using the brass soldered to iron chassis here, right? Good shielded case. And in here is the output amplifier tube, and the attenuator here is a capacitive coupling. So here you couple the output drive, and then you have a mechanical output selector as well. As you see here, everything is quite corroded, really bad here on the aluminium coating, something under the paint. It's just falling apart basically due to corrosion. And this is bad. You can see here I definitely need to go outside and clean all this and see if I'm able to get it to just a decent state anyway. But the schematic from Radio Museum, that is not the right schematic. So obviously this is the special version I got, and this is the normal version. So there's one extra tube in my unit, by the way. And if we look at the schematic here, the oscillator that is made by 2 triodes, and in my unit it's made by an EC903. So I believe that is a completely different tube, like that one, right? And also you see I got 1, 2, 3, 4 tubes, and they're mounted completely different. If I show you this picture here, let's see here from different angles and all that kind of stuff. So you will see the 4 tubes I got here in the oscillator box. And let's just try and plug in a picture from Radio Museum from, I think it's Anton I can't even explain. I can't even read his name, but there's some dude who uploaded those pictures, and I will show you his picture, and it's a completely different unit. The 3 tubes there are mounted in a completely different way. So yeah, that's just the way it is. So this is a different unit with 1 more tube. That's just the way it is. So we don't have exactly the schematic for my unit, and that is a little bit annoying. So yeah, I will have to guess a little bit. So here is my plan. I found another transformer with a filament winding and a high voltage winding, variable input, a lot of tappings for the input, so I can fine tune high voltage and filaments. However, this transformer only got 1 filament winding, and I need 2 individual filament windings because 1 is driving the EL86. Remember, this is the high voltage regulator, and cathode is high. So of course that filament winding needs to be individual, isolated, and capable of handling high voltage, right? All the other filaments for all the other tubes, they are more or less in parallel. All the wires, they come in here. Those 4 wires, this is what we got for filaments. I just put all these in parallel. So I will just feed these with DC from a normal power supply, so I can heat those up, and then I can play with the high voltage and the filament for the high voltage regulator. So I think I'm quite ready to power this up and see if I can bring it back to life once again. So I would like to add this info to the schematic. We got 280 AC from the transformer. The 2 green wires, that will be the heater for the EL86, and that is 0.8 amps. And all the other tubes in parallel, that's 1.2 10.8 amps, and that's orange wires. Let's see if I can get everything in the picture. This is a little bit difficult because this unit is really, really big, but you can see some of my scope here, right? And I got, of course, filament on all the tubes. And what I can do now is apply voltage to the high voltage part, and it is using 50-60 watts, and hopefully I should get some output. Let's see. Is the high voltage? Yeah, look at that. Here is my output. And that is 10.7 megahertz, and that is exactly what I have done here. Oh, let's have a little look. So there you go, 10.7 megahertz is written right there. And yeah, it's not super clean, but that is how it looks. And what I've done is, that is the range for 10.7. Is this reacting? 10.8. And then 10.6. Yeah, all that seems to be working. I really like the tuning here is so smooth. But there's a fat-filled joint shaft thing in here, so it's really nice. And then the strings to the big wheel here, and this big readout here is just fantastic. And here is AM modulation. Look at that, it's beautiful. And the fun thing is you can actually hear the tone goes like wee. That is great. So that really works too. So here's a funny little thing that I'm trying. So this is a little 2-meter radio receiver, right? And as you can see here, the green lamp is on. So that means my carrier is now detected. I am actually in 72 megahertz range, or this is my output setup here. So my second harmonic is in the middle of the 2-meter band, 145 megahertz. And the reason for doing that is because the last few bands on the main dial here, they're not working. So it goes actually down in frequency instead of up in frequency. So there is some loose connections or some coils that's not working, or the oscillator is tired or something like that. But it's nice and quiet right now. So here we go. See? So this is the modulation. But when I enable modulation, it actually also affects the frequency a little bit, and then it moves out of the channel. So see what happens here. I can't even get the exact point. It is that funny. So this is yeah, well, it's not super useful to inject any kind of FM, but I think it has something to do with the design. This is probably the earlier version with a tube here. This is the oscillator, and my model here got a tube, a diode, single diode tube, the EC92 here. The later version got those two FM diodes here, and they generate the FM via this injected FM signal, and then they affect the tuning, and I believe that is a better way to do it. And yeah, so anyway, I got this thing up and running. We got carrier, we got signal, we got modulation, we got AM, we got FM. I don't really want to show you a lot more, to be honest. So thank you very much for watching, and I hope to see you soon again. Bye bye.